Hey, it's Mr. Saltano here, and today's lesson is going to be on mixtures. So, a bit more vocabulary for us to cover in this unit. We're going to be looking at mixture, heterogeneous mixture, homogeneous mixture, solution, and alloy. So these are the vocab words you're going to want to be listening for as we go through the lesson. So, a little rehash from our last video. We were talking about elements and compounds, and we said that they were both pure substances. So they both qualify as pure substances. For example, if you have oxygen, that's going to be oxygen all the way through. There's nothing in there except oxygen, right? Even though a compound will be comprised of at least two types of atoms, it's still going to be just that compound all the way through. So for example, salt is just going to be salt all the way through. Something else I wanted to mention is that these can only be changed by chemical changes. So the only way to change an element into a compound or vice versa is by a chemical change. So if you want to create those bonds or break those bonds, the only way to do that is by a chemical change. And I wanted to show you what I mean, because this will be important for differentiating between these and mixtures.
Here is an atom. This one is an iron atom. Here are some more. And here is some sulfur. Now, when you bond two elements together, you can make new and wonderful compounds. Drag the elements together and see what happens. That chemical reaction created bonds that fuse the elements together. Just try and separate them. Go on, try it. No, it's not going to work. That's because we've created an entirely new compound. Iron sulfide, which is nothing like iron or sulfur. The only way to pull them apart is another chemical reaction. These things here are molecules, a bunch of atoms bonded together. This is an oxygen molecule, but you can also get molecules made up of different kinds of atoms. We're about to see how. Here is the element hydrogen. What happens when you fuse it with oxygen? You try it. Explosive. That reaction created a lot of energy. It also gave us these molecules with one oxygen and two hydrogen atoms. See them? Hydrogen and oxygen were gases at room temperature, but bonded together, they become an entirely different compound, water. Yes, this is a molecule of water. If there is no bonding, then elements and other substances just kind of mix together to form a mixture. Use the fan to mix up the elements here. Because they're not chemically joined, it's much easier to separate the elements in a mixture. Try and separate them now. Actually, it's not usually that easy. Atoms are really, really tiny, and you might have trillions of them.
So we are back now, and that's essentially the key difference between a mixture and a compound or an element is that it's much easier to separate. You cannot simply break the bonds that are in an element or a compound because those are chemical bonds. You'd have to do a chemical reaction to break those bonds. So a mixture essentially is combinations of two or more substances, so pure substances, that can be separated by physical methods and have variable composition. So that means, for example, we have our trail mix over here. That can be separated just by pulling them apart, right? That's a physical means of separating them. And you can have different number of nuts, different number of raisins. It's a variable composition. It could be different things. Same thing with these M&Ms here. This is a mixture that we could simply separate. No chemical reaction required to separate any of these. Same thing with the ice cream. We could separate those ingredients. Here is our submicroscopic view of mixtures. Can you tell what A is a mixture of? So what do you think is in there? I'll give you a hint. It's a couple of pure substances that we talked about. And what about B? B is a mixture of something else. What is B a mixture of? And then C? C is also a new mixture that we have. So notice this compound that's in mixture B, the only way to separate the black atom from the red atom would be by a chemical reaction. So that's because this is a specific compound. But the overall piece is the mixture, right? We have more than one thing mixed together here. And the parts of the mixture, like this compound and that different compound, can be pulled apart and that's what makes it a mixture. There are two different types of mixtures we're talking about. One is heterogeneous, so we'll start with that one. So remember, a mixture is at least two substances. What makes a mixture heterogeneous is that they're not evenly distributed throughout the mixture. So for example, if we look at this mixture on the left here, it's got a bunch of pieces in there that are all over the place. This one's just completely split up, right? Here's our solid form, here's our liquid form, or at least different colors. So that is a heterogeneous mixture over there. If we look at our homogeneous mixture, a homogeneous mixture simply means that it is spread throughout equally. It's uniform composition throughout the entire thing. In fact, you can't tell the difference between one part or another. Another name for a homogeneous mixture, which is another one of our big vocab words, is a solution. So if someone's talking about a solution, they're talking about a homogeneous mixture. And again, key difference, heterogeneous mixture, you can see the difference. You can see a separation between the pieces. Homogeneous mixture is the same all the way throughout. You can't see the difference. So if we're rehashing this again, one way you can actually tell the difference in a heterogeneous mixture, mentally in your mind, let's look at this this rock, for example, at the bottom. If we take a section of this in our mind, and then we look at another section, they're different from each other, right? So if you can grab a section of it and it's not exactly the same as another section, that makes it a heterogeneous mixture, because there's more than one types of rocks mixed into this rock. A homogeneous mixture over here, like Kool-Aid, if I grab a section of this Kool-Aid, it's going to be exactly the same as the rest of the Kool-Aid. And so that's what makes Kool-Aid a homogeneous mixture. So again, heterogeneous, different at different parts. Homogeneous, it's the same all the way throughout. Another key thing about heterogeneous mixtures is that they're always cloudy. You can't see through them. They're not transparent. Kind of like you can see a little bit through Kool-Aid, right? You can see through salt water, for example. Salt water is a homogeneous mixture. A heterogeneous mixture you cannot see through. Milk is another heterogeneous mixture that you just simply cannot see through because it is not evenly distributed. So if it's not clear, it must be heterogeneous. Here's our submicroscopic view. If you look at this homogeneous mixture, if I were to grab this section at the top left and then compare it to the section just around it, it's all going to be the same. This is distributed evenly all the way throughout this mixture. There's no difference really. This heterogeneous mixture is far different. It's very different all the way throughout. There's some big chunks of blue at the top right, little orange at the top left. It's not even at all. In fact, what would you expect this heterogeneous mixture to look like from a macroscopic view? Would you think that would be cloudy or clear? Okay, here's a couple of examples to kind of quiz yourself. So take a look at these and see if you can guess what kind of mixture we're looking at. For the top left, what do you think? Homogeneous, heterogeneous? And air, just air in general. What do you think about this cereal? Homogeneous, heterogeneous? Feel free to pause the video and quiz yourself on these, by the way, as I ask, because I'm going kind of quickly. What do you think about this pizza over here is heterogeneous? What do you think about the salad? Heterogeneous. What do you think about the water? Salt water. Actually, there's salt in there. If it was just water, it would be a compound, right? But because there's salt in there, it's a mixture. Heterogeneous or homogeneous? What do you think about Tide? Not the bottle, but just what's in the Tide. And finally, what do you think about the trail mix? Heterogeneous. And one of the last bits of vocab for this unit is just an alloy. So if you wear any jewelry at all, any kind of earrings, any kind of rings, or if your parents wear jewelry, anybody you know wears jewelry, jewelry typically contains what's an alloy. And an alloy is simply a solution, right? So a homogeneous mixture of different metals. So I'll give you an example. You've heard of sterling silver, right? Sterling silver is different from regular silver. Regular silver is an element, which is on the periodic table. Sterling silver is actually made of a little bit of silver, mostly silver, and a little bit of copper. So that makes it sterling silver. If you've heard of someone say 14 karat gold, that means that carat part is talking about how pure that gold is. Gold you wear is never going to be fully pure for a bunch of reasons. So 14 karat gold, for example, is only 58% gold, anywhere from 14 to 28% silver, and anywhere from 14 to 28% copper. And the reason why is because pure gold is very dense, it's very heavy, right? And it's also very soft, believe it or not. If you were to wear pure gold jewelry or pure silver jewelry, it would be you'd be able to manipulate a little bit. It wouldn't stay on your finger. It would get smushed in your daily activity. So that's part of the reason we have to kind of make it not pure. It's also less expensive, right, if it's not pure gold or pure silver. So that's what an alloy is. It's a homogeneous mixture of metals, essentially. And you can't tell the difference, right? That's what makes it homogeneous. You can't spot the difference in the metals. So essentially we looked at, before we started this, pure substances, elements and compounds. We said that they couldn't be separated except for by a chemical reaction. Now another part of matter are mixtures. And we looked at heterogeneous mixtures and homogeneous mixtures. So let's do now a quick vocab rehash. Two or more substances which can be separated by physical means. That would be a mixture. A mixture uniform in composition. That would be a homogeneous mixture. A solution of more than one metal. An alloy. And another word for a homogeneous mixture is a solution. And then finally, a mixture that is not uniform, it's not the same throughout, would be a heterogeneous mixture. So that does it for us for mixtures. Thank you for watching. And remember, chemistry is everywhere.